In this video, we'll be talking about small portable air conditioners. Now, we're going to break this analysis into two parts. The first part will involve talking about units in terms of small or low cooling capacity and therefore a lower area of coverage. In the second part of this video, we'll talk about the actual physical size of different units and how that might impact the cooling capacity and the area of coverage. So let's begin with a discussion on cooling capacity. Now, most portable air conditioners on the market can be divided into four different size classes: 8,000 BTU, 10,000 BTU, 12,000 BTU, 14,000 BTU. And generally, the higher the BTU, the greater the cooling capacity of the unit. And therefore, you might be inclined to think that the higher the BTU, the greater the area of coverage for any particular unit. However, this is simply not the case. Our own research and testing has shown that there's really only one size portable air conditioner that you should be considering, and that is a 14,000 BTU unit. So why do we say that? First of all, portable air conditioners are inherently inefficient appliances. The unit we have on the table here today will serve as a demonstration of how portable air conditioners work. So on the back here up top, we have an evaporator. So how the air conditioner works is it pulls air through this top part here, and then it outputs it through the top here on the front of the unit. The unit is actually turned with its back towards the camera. So up top here, what you cannot see is that the air comes and it exits through the top of the unit on the front here. So it enters on the back here and it exits on the front. So that is the main direction of the air through the unit. However, the AC unit also requires its condenser to be cooled. So at the same time, air is pulled on the bottom here, and that air is pulled over a condenser. And the condenser is hot. So as a result of all of these processes, the unit exhausts hot air. And the unit exhausts hot air through a duct that fits onto the back of the unit here. The duct isn't currently connected, but you can see here another grill here, and that is where hot air exits out of the unit. So the hot air travels through a duct, out through a bracket that you put into your window, and to the outdoors. So where are the inefficiencies here? First of all, the unit is taking in cooled room air through this grill on the back here to cool its condenser. And what that does is it creates an area of low pressure inside of the room that is being conditioned. So relative to the outdoor air, which is very hot, the room that is being conditioned is going to be at a lower pressure. So there's a pressure gradient that exists there. And what happens is that hot outdoor air is constantly getting pulled into the room because of that pressure gradient. So remember, the unit has to cool its condenser. To do so, it pulls the air in through this bottom part here, and it's cooling that condenser constantly as it's working. And because it's pulling in air from the room without actively working to replace the air from some other source, there's an area of low pressure in the room that causes that pressure gradient, and that hot air is constantly getting pulled into the room. So that causes the unit to be inherently inefficient just for that reason alone. A secondary reason why it's inefficient is the duct that sits on the back of the unit here. Now, that duct is exhausting really hot air, and the duct is not made of a highly insulated material. It's made of a thin plastic. So that duct is also radiating heat back into the room. And that heat getting radiated back into the room, in addition to the heat getting pulled into the room because of that pressure gradient, those two inefficiencies combine to make the unit inherently inefficient. And that's why portable air conditioners really get a bad rap all around, is because of those inefficiencies. The unit is one all-in-one portable AC unit. All the AC components are in here. You can easily move it from room to room. However, the major cost here is those two inefficiencies. So in the past, units have been rated according to their cooling capacity by a method of testing that involved not taking into account those inefficiencies. So this unit on the table here today is a 10,000 BTU unit, and it's 10,000 BTUs based on the old standard of measurement. By the new standard, this is actually a 6,500 BTU unit. So what that means is once you take into account inefficiencies like heat added by ducting, heat added by outdoor air getting pulled into the room, this unit goes from a 10,000 BTU unit to a 6,500 BTU unit. And you can see here why we argue that you really should only consider 14,000 BTU units. The truth is that if you are buying an 8,000 BTU unit, if you're looking for a unit that's a small unit for a small room, you're not really buying an 8,000 BTU unit. You're buying a 4,400 BTU unit, maybe a 5,500 BTU unit at best. So that 8,000 BTU unit has an actual cooling capacity that is much lower than that 8,000 BTUs might seem to indicate. Once you move up to a 14,000 BTU unit, The most efficient 14,000 BTU units are going to output at about 10,000 BTUs once you take into account those inefficiencies. The worst performing 14,000 BTU units are going to be closer to about 7,000 BTUs. So even within the 14,000 BTU category, you have an actual cooling capacity that is similar or even less than this unit's BTUs by the traditional standard for measuring BTUs. So the bottom line here is whatever portable air conditioner you buy, keep in mind that it's not going to work nearly as well as that traditional BTU measurement, sometimes called an ASHRAE BTU measurement, is going to appear to indicate. And the end result here is that smaller units, 10,000 BTU units, 8,000 BTU units, even 12,000 BTU units, are going to have an actual cooling capacity that's just not sufficient for most applications. Yes, if you have a very small room, we're talking about a room maybe less than 150 square feet or so. If you have a room that is not very challenging to cool, in other words, a room that maybe is not in that hot of a climate, that's maybe not in a second story, that maybe doesn't have a lot of windows, if the room is not especially challenging to cool and it is very small, then yes, absolutely, you can get away with a small unit like this, a 10,000 BTU unit by the traditional method for measuring BTUs. However, if your room is any larger than about 150 square feet, if the room is especially challenging to cool, maybe you need to cool a room in the middle of the summer when temperatures are getting to 100 degrees Fahrenheit, even 90 plus degrees Fahrenheit. In that scenario, a 14,000 BTU unit, which remember has an actual output closer to about 10,000 BTUs at best, a unit like that is going to be absolutely critical for you to effectively cool the room. So what we're trying to say here is portable air conditioners are inherently inefficient appliances. If you're shopping for a small one, keep your expectations in check. It's not going to work in challenging environments. It's not going to work in anything other than a very small room. If you do want to buy a unit for most applications, for most situations, you have to step up to a 14,000 BTU unit. Now, in terms of physical size, the truth is that most portable air conditioners are very similar in size and weight. This 10,000 BTU unit we have on the table here today is a large appliance. It's a very heavy appliance. It weighs over 50 pounds. Even if you move up to a 12,000, a 14,000 BTU unit, yes, maybe it will increase by a few inches in size. Maybe it'll increase by a few pounds in weight, but it's still a heavy appliance, just like small portable AC units are heavy appliances. So there is no real benefit in terms of size or weight when you move to a 8,000 or 10,000 BTU unit. It just doesn't work that way. All portable air conditioners are large and heavy appliances. So what are the main takeaways for this video? The bottom line here is that cooling capacity needs to be the primary driver for your purchase decision. Do not buy a small air conditioner, a small portable air conditioner, thinking that it is going to be physically smaller than higher capacity units. It just doesn't work that way. Do not buy a small capacity unit thinking that it is going to be able to readily accommodate a medium-sized room or a room that gets really hot. It's just not going to be able to do that. These are inefficient appliances. To make an appliance like this, an appliance that is designed in this way, work even in a small room, if it's a challenging environment, you have to buy the highest capacity unit you can possibly buy. And that is going to be a high capacity 14,000 BTU unit. Now, we have several recommendations for those units that are currently on the market that fit the bill there. We will link to them in the description of this video. So if you are looking for a portable AC unit, even for a small room, even for a smaller application, those units would be our recommendation.